So now that you've watched the video on substitution, let's try some word problems involving substitution. So let's look at the first one. Julio and Rich have a rematch of their race. Rich runs 7 meters every second and has a 20-meter head start, and Julio runs a 10 meters every second. So he's not getting any head start, right? He's starting from the starting line. And Rich, who's a little bit slower, gets a little bit of a head start. So we basically want to find that the point of this question is we want to find when Julio catches up to Rich, right? That's the point of the question. So if we want to visualize these as two lines, I'm just going to draw a quick sketch on the side. Rich starts at 20 meters, so he's going to start, if this is the distance here, and this is the time, he's going to start at 20 meters, right? And he's going to move 7 meters every second. So I just sort of drew a random slope there, but let's pretend that that's 7 meters every second. Julio starts at the starting line, so starts at a distance of 0 meters, and he runs 10 meters every second. So his line is going to be steeper because he's going faster, right? So it's going to look something like that. At some point, Julio is going to catch Rich, right? And we want to know when that happens, right? It's when these two lines cross. That means they're in the same place at the same time. So we want to know when that is. So we could do that with a graph or with a table of values, but the grade 10 way to do that is by using a little bit of algebra, so either substitution or elimination. In this case, we're going to use substitution just so we can get a little bit of practice with it. So the first step in order to use substitution, just like elimination, is to create an equation. We need to create an equation for each of them. So Julio, how can we represent his running, his distance, given some time? So we're going to know it's going to be d, right, for distance, is equal to, well, he runs 10 meters every second. So at 0 times 0, he's going to be at a distance of 0. At time 1, he's going to be a distance of 10. At a time of 2 seconds, he's going to be a distance of 20. So it's just going to go up by 10 each time. And we should know by now, to make an equation for that, it's just going to be 10t, right? Or s. It actually says in the question to use s for seconds. So let's use s. Let me erase that. Let's use s. So 10s for seconds. So it's going to be 10 times the number of seconds that have passed. Rich, on the other hand, his distance is going to be, well, he starts with a 20-meter head start. So he already has 20 meters under his belt, and then he adds 7 meters every second. So it should be something like that, 7s, right? So now we use substitution to find where the distance and the time are going to be the same. So remember substitution, all we do is we know these two d's are going to be equal to each other, right? So that means these two equations are going to be equal to each other. So we know 10s is going to be equal to 20 plus 7s. And then I want to get the variables on the same side. So I want to get the 7s to the left side. So I'm just going to subtract 7s and subtract 7s to get rid of those. What am I left with? Well, 10 minus 7 is 3s, and on the right side, what's left is 20. Now to finally solve this equation, to get rid of that 3, I'm going to divide by 3, and I'm left with s equals 20 divided by 3, which is, 20 divided by 3 is 6.67. If I round to 2 decimal places, 6.67 seconds. I'll put SEC for seconds so we don't get confused. Okay, so that's how long it takes. So that's the amount of time it takes right here for them to meet. But we also want to know how far they've gone, right? What is the distance that they meet at? And we could easily do that by just plugging this time into either one of these equations. We should get the same answer. So notice how this one is a lot easier. D equals 10 times s, because all we need to do is multiply that by s. So this is for distance. I'm just gonna put that for distance. This is to solve for the distance. we know D equals 10 times S, which is 6.67, which if we multiply 6.67 by 10, it's just going to be 66.7 meters. So after 6.67 seconds, they are both at 66.7 meters. So a nice little extension question here is, if the race was 100 meters, who would win? Well, 100 meters is going to be further than 66.7 meters, right? 100 meters is going to be like up here. So who gets to that 100 meters first? Well, if you look on that graph, it looks like Julio gets to that 100 meters in less time than Rich does. Rich takes longer to get there, which makes sense because Julio started off at a disadvantage, but then caught up and passed him, right? So there we go. Rich would win a 100-meter dash. Okay, so now what I want you to do is I want you to try question 2 yourself. So sort of similar, same idea. And part B asks you who will win the 100-meter race, so similar to what we just talked about. So I want you to try this one yourself. Pause the video here, try it yourself, unpause it, and you will see the solution. So that's the solution I got. This answer here is actually wrong. It should be 4.62 seconds, not 8.6 seconds. So the answer is 4.62 seconds, and that's a distance of 55.4 meters. So who would win the 100-meter race? Well, remember, Rich started off with a head start, but Julio caught up at 55 meters, right? So if he caught up at 55 meters, that means everything past that, he's ahead. Julio is ahead. So if Julio's ahead, that means he's going to be ahead at 100 meters. So Julio is going to be faster at the end. He's running faster, but he's also going to win the 100-meter dash. Okay? It would be different if the distance he caught up in was over 100 meters, right? Okay. So there's some more questions here, and I want you to try these. They're a little bit tricky, but for question 3, I'm actually going to help you get set up. Notice, by the way, how the answers are all on the page, so you can double check as you go that you have the correct answers. But I want to help you get set up with the equations for question 3, because it's a little bit tricky. So Catherine's selling t-shirts. The supplier charges $210 design fee plus $3 per shirt. Catherine plans to sell the shirts for $10 each. So we want to know, the point of this question is we want to know the break-even point, because it costs Catherine money to buy these shirts for herself, and then she's going to resell them. So we want to know how many shirts she has to sell to make a profit, because buying the shirts is going to be expensive at first, so she has to sell a lot to make up that price, right? So we need 2 equations. We need the cost equation for Catherine, and then how much she gets from sales. For each of these, it's telling us to use M for the money that she makes or has to spend. So for the cost, money is going to equal, well, how much does it cost her? The supplier charges $210 design fee, so that's like a total cost of $210 that she always has to pay, and then $3 per shirt. So if that's the case, it's like she always needs to pay this $210, but for every shirt, she also needs to pay $3. So plus 3T. T represents the t-shirts. So that's going to be our equation for the cost there. For the sales, so this is how much she sells them for. She's just selling them for $10 each. So how much money is she going to make from selling them for $10 each? Well, 10 each. Remember, if T stands for t-shirts, it's just going to be 10 times the number of t-shirts, 10T. Those are your 2 equations. So using those 2 equations, I think you can do the rest. The break-even point is where those 2 things cost the same. The number of shirts are the same and the cost is the same. So you can figure out that part, and the answer is on the page. Okay? And then try it for the remaining questions. Okay? Good luck.